infinity. So here we go. And we're back. And basically, to start where we just left off from, like I said, each time by pushing down a fret, you're sharpening the string, and on each fret, you're creating a higher pitch, a higher note. Okay, so each one of these steps is going to be a higher note. And basically, like I said, you got a 12 steps till you get back to your octave. All right, now we're gonna talk about octaves. What is an octave? Okay, when you go from an A note to an A note, it's an octave. When you go from a B to a B, it's an octave. You can, whatever note you're starting on, you go up 12 steps, and you're back to 13 steps. Actually, there's 12 steps in between there. On the 13th step, you're back at the same note again. Okay. And wherever you start, you take those 13 steps and you're back on the same note. Now, that's going to be an octave. Now, the thing is about music, the important thing about notes, and it's not which note you pick, okay, or the note itself that's going to sound, that's going to give off the right sound, okay. It's the relationship between notes. All right. Now, and when I say the relationship between notes, the relationship between frequencies, and I'm going to explain that by, we're going to talk about octaves, okay. And like I said, octave, O-C-T-A-V-E, some Latin, Greek word, I don't know what the hell it means, where it started from, but it means 8, okay? And now we're going to talk about, that's getting into a whole other story. I'm getting a little off track here. But basically, let's go ahead and let's talk about the octave here. You got, there's the E, the low E, and the high E, okay? Now, what makes this, like I said, they did the 12 steps, okay, between the two frequencies. Now, the way they organize it is that when you get the 13 steps past any note, okay, you can pick this note here, and you go an octave past that note, you're going to be looking at the same relationship, okay. The relationship between these two notes is going to be the same as the relationship between these two notes, okay. And to explain that is, the way to explain that is, once you take those 13 steps to get to that next note, the frequency of that higher note is exactly double the frequency of the lower note that you started off with, okay? So the frequency of an A to an A, the high A is double the frequency of the low A. And what makes the octave an octave is, we're talking about, let's dig into the frequency itself, okay? The sound you hear. And when I say the frequency is double, okay, all sound travels at the same rate of speed, but the sound waves within that, the waves of sound within the sound itself, is what I'm talking about when I say this, the frequency is double, okay? And what they do, and you have to try to picture sound waves, okay, traveling through the air, okay? One's vibrating twice the speed, so they're going to kind of reinforce each other, okay? When the sound hits your ear, one traveling with one vibrating twice as fast as the other one, they're going to reinforce each other, and it's going to hit the ear. The frequencies are going to end up doubling on the ear, pretty much, eardrum. All right. Now, it's the relationship between those. It's tough to explain, okay? But you have to be able to kind of visualize that in your head, okay? Look at, picture the two frequencies, and one is exactly double, so that when one frequency travels twice, the other one's traveling once, okay? And when they coincide like that, and they're perfectly in harmony, it hits the ear, and they sound, basically they sound the same, okay? Now, the relationship between those two notes is what makes it an octave, okay? It's not a specific pitch, it's just the relationship between those two. So you can say this, and here he goes an octave, E to E, and I know you can't see what I'm doing here, alright? But basically, that's the concept, and I hope you caught that grasped that concept, and I hope I explained it well enough for you to understand it. But and based on like I was saying earlier, so you see how it's not the note itself, but the relationship between one note and another note that makes an octave an octave. All right, so let's continue. We're going to talk about, well, I'll explain to you what an octave is, right? Now I want you to be able to distinguish between an octave and the exact same note, alright? They're both called the same thing. An E and an E could be, okay, this is an E, and this is an E. That's your octave. I'm sorry, let's talk about the A note instead. Just, they're different frequencies, different pitch, okay? This is an A note. This is an A note. Okay, now they're the exact same note. These are the exact same frequency. hitting two different strings. I'm hitting the first string on the 5th fret, there, and I'm hitting the second string open. They're both the same note. Now, to hit an octave, I want you to hear the difference between the same note and an octave. They're all three of these notes are A's. A, A, A. These two are the same. These two are an octave apart. These two are an octave apart. Alright? So, I'm not sure if you can catch that or not. If you can't, like I said, anything, and this is the first time I've ever tried to throw these concepts at anybody through webcam, and it's pretty difficult to teach like that, because I don't know if you're understanding this or not, but I'm going to have to go on and assume that you are. If you're not, then just ask me questions about it later and we'll go ahead and fill in the blanks, alright? So we now, hopefully we know the difference between the same note and notes, the octave higher. They all call the same thing, like I said, A, and A. Alright, now the next thing I want to get into, something in my eye. The next thing I want to get into is the pattern, and this is important, the pattern of the notes and how they're laid out on the guitar. Okay, now you're not about to start memorizing the notes and where they're at in the location. I just want you to be able to see the pattern. The notes are laid out in a specific pattern on the guitar, and once you understand that, you'll be able to understand the concept of how I can find an E note here, an E note here, an E note here, an E note here. They're all over the place, and the last string. These are all E notes. Okay, but once I explain that to you, you might be able to understand the concept of how that's possible. Okay, so here we go. We're going to count, like I said, you can count the chromatic scale, which is all 12 steps to get to the next octave. Okay, we're going to do that like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then bam, you're back at 8. Okay, but you can do the exact same thing by going all the way up on the first string: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now you hear this, just like these are the same note: E, E, and this is another E right here. 1, 2, 3, all the exact same frequency, the exact same note. Okay. Now I'm going to explain how that's possible. All right. I know we already talked about your string thicknesses, the vibration of them, and it's going to give off, because they're different thicknesses, they're going to give off different pitches for different notes. Okay, different sounds. Now, like I said, as you shorten the strings, you're giving off each one of those a step towards another note. Okay, and not towards another note. Each one of these steps is another note, because it shortens the string and it makes the string vibrate faster, and the result is a higher pitch, the next note. Okay. Now, by shortening the string all the way to the 5th fret, the 5th fret top string, this top string is vibrating and is producing the same pitch as hitting the 2nd string open. That's how it's possible to have the same note, okay, on two different strings, the exact same note. All right. So, bam, you're looking at A note here and an A note open on the 2nd string.